All right, so let's talk about the last topic of homework 2. Cross-site request forgery attacks. So cross-site request forgery, this is an attack vector that can be used. We're going to learn what it is and how to prevent this. And for some reason, so sometimes it is CSRF for cross-site request forgery, but in the world of the internet, for some reason, people decided that we like to use X's for cross. So whenever you see an X, that's usually going to mean cross something. Like the cross-site scripting attack, I forgot to call it by this name in the other lecture, where you can inject JavaScript using an HTML injection attack. That's usually called cross-site scripting, or XSS. So the cross, if you ever see that X, it usually means cross, meaning that we have two different sites. You have your attack site and the site that you're attacking, and you get your users to have something over here where they're attacking something over here. So you get somebody to click on a risky link, and it ends up attacking their banking profile or something like that. That's the cross part of that. Usually we're going across different origins. So cross-site scripting, this is when we're going to have an attack, cross-site scripting, cross-site request forgery, when we have a request being sent from another site. So, for example, we have a form which is going to send post requests. This post request is going to be sent by the user to send messages to the chat. Effectively, for homework 2, it's an image bulletin board, so they're going to post an image and some message along with that image. They're going to be able to send information to our server. The cross-site scripting attack, to do this, some attacker is going to have their attack site, which is going to send a post request on the behalf of a user, typically without their knowledge. So you click on some risky link, it's an attack site, it's going to have some JavaScript, which is going to send an AJAX request. We'll formally introduce AJAX on Friday, but for now it's a request. It's an HTTP request that doesn't trigger a page load. So it doesn't reload the page, and it can happen in the background without your knowledge. So the JavaScript, write some JavaScript that sends an AJAX request that sends this post request to your site and uploads whatever image and comment the attacker wants on behalf of the user. So if you're browsing, whatever, and there's some JavaScript that's going to make a post on your favorite social media site that is probably something you don't want posted, whatever the attacker's going to do, they could make this cross-site request forgery attack and be able to post whatever the hell they want as you. It'll show up on your account, and it'll look like you posted it, but it was actually just an attacker because you clicked on a risky link. That's a cross-site request forgery attack. That's what we want to protect against. So some things that users might do if they have an attack site that, say, is going to attack Autolab. Whenever you go to this site, they're going to request your grades off of Autolab. This is something we really have to think about when we're developing Autolab. We can't allow this. It's a FERPA violation. It's a federal violation. We get in a whole bunch of trouble. We can't leak your grades. It's one of the big things. It's one of the big responsibilities of my job. I can't leak your grades. So what if somebody has an attack site that makes a request to Autolab for your grades? They have JavaScript that reads that and then sends it back to their database with another AJAX request. So they could effectively steal your grades if you click on one of these attack links. Or even worse, if somebody injects HTML into an insecure site that a lot of people are using, they don't even have to host their own attack site. They can have somebody else host it. Or they can make submissions on your behalf. Maybe maybe you really piss somebody off and they want to make a submission that it gets a little involved if you would have to really piss somebody off. But if they want to steal somebody else's code and then do a cross-site request forgery attack on you, get you to click a risky link, and then submit somebody else's code as your own, and then all of a sudden both of you are in my office because it's academic integrity at that point, somebody could potentially do that. Of course, Autolab's protected against cross-site request forgery, or else I wouldn't be giving you these ideas. But these are some things they can do. Or Maybe you don't even, maybe grades doesn't do it for you. Maybe it's all about money. What if they're doing this with your bank account? They send a post request that says, hey, transfer these funds from this account to the attacker's account. Well, now they can just steal your money because you clicked on a link. That's no good. We don't like any of this stuff. We don't like to allow any of this stuff. So how do we prevent against these attacks? Luckily, it's not too hard. Just like the other security things we talked about, it's not too hard. Security is such a big topic on the internet. There have been decades of, literally 2 decades, but it's still plural, of people building new ways to prevent against these attacks. The internet hasn't been around that long. Usually I say it's been forever. They've been working on this. Not really that long. That's why there are still so many successful attacks. But the basic attacks, we got these ones pretty well covered, but it is still something you'll have to do in your code. So we have something called CORS and the same origin policy. CORS, SOP, same origin policy, and CORS, cross-origin resource sharing policy. So by default, what the browser does is whenever you have one of these cross-origin requests, you clicked on a link, you got HTML for a page, that HTML has all kinds of links in it, it makes all kinds of other HTTP requests to get the full page. The origin is the domain and port of the that sent you the HTML, the root HTML, the first request that was made in that chain. There might be a whole bunch of other stuff that happens after that, but the very first one, that's the origin of the page you're navigating. The browser's going to write that down. It's going to note that, okay, the origin that you're at right now is whatever site you actually went to. You went to autograder.com, autograder.buffalo.edu. You went there. That's the origin. And whenever there's a request, whenever it's making all those subsequent requests to get the rest of the page, it's going to look at that origin. If the origin's the same, the browser's like, oh, yeah, it's the same origin. Who cares? But whenever the origins don't match, that's when we have a concern, and that's when the browser goes into high alert and says, okay, you're requesting something from a different origin. Let me slow down a bit and let me think about this. Is this okay? And in most cases, I know one of these bullet points is it, but my eyes are just bugging. In most cases, the browser's just going to say, nah, not going to allow it. We're just not doing that. We're not playing that game. There are some exceptions to this. If it's multimedia, the browser's usually okay with it. If it's a GET request to multimedia, usually the browser's going to say okay. So this is why in like 199, you can get away with creating an image tag, and then in the source, just copy and paste a whole frickin' link from a different origin. You're usually going to get that image because the browser's like, okay, you're just making a GET request for multimedia content, whatever. As long as the other origin doesn't explicitly restrict that, the browser's going to be like, okay, we're good, and get that site, get that multimedia content. Just about anything else, by default, is going to be blocked by this CORS policy from the browser. The browser's going to say, I'm not making that request. And JavaScript libraries. I believe those are usually overridden, though. If like a CDN that's hosting, like say if you've used Bootstrap in your page, you usually have the URL for a CDN in your script tags. You say, give me this script and this JavaScript and this CSS for Bootstrap, or whatever libraries you're using, jQuery, for example. You usually paste the full URL in there until you're hosting your own libraries, which you should do eventually if you're out there, if you're deploying to production. It's going too much of a tangent, but I had a really strange bug where I was using a CDN for a library. It's probably Bootstrap. I just stuck with Bootstrap for my styling. But I had an issue where the CDN had a little bit of a delay on it, and sometimes even requests were being timed out. It was just having a slow day or whatever. And you would go to my pages on that day, and you just wouldn't get the Bootstrap. So it would just look like absolute crap, because it would be my content with zero styling. And without Bootstrap, I mean, like look at cc312.com. It's pretty much all Bootstrap for the styling. I don't want to do my own CSS, and I don't know. I learned Bootstrap once, and I'm like, this is good enough. I don't need to learn another one, another front-end library. for styling. So my pages just look like crap after that. So ever since then, I always hosted my own libraries. You download the library, and then you host it as content from your site. So eventually you should all do that, unless you want to run into that same issue that I had. But those libraries are usually explicitly allowed. The CDN, the whole purpose of a CDN, Content Delivery Network, the whole purpose is to deliver content. So they're not going to restrict you to the same origin policy. Not many people go to the CDN's website to request that content. They want to allow cross-site requests. And I don't have too many slides on this. We'll see a lot of demos. It's actually, I got to add that to the demo list. I want to show that one too. And when we're in the demos, especially, if you want to hit me up in chat, if there's something you want to see, it's going to be pretty much freestyle in the demos. I got some things planned, but whatever you want to see. This is true for any time I do live demos, in this class especially. If there's something you want to see, let me know, and I'll go that way. Because whatever I have planned, maybe y'all already seen that, maybe y'all know about it, or maybe it's just flat out not interesting. So let me know what you want to see in the demos. So the whole point of the demos is to get you to learn the material better. All the slides are everything you need to know about this, at least in this class. The demos are just to show you something interesting, so let me know what's interesting to you. All right, so cores, usually, there's my bullet point. Usually blocked by default. The browser's going to block most things, especially if it's at all suspicious, it's going to block it. If you want to allow those requests, you can override cores. Not recommended. There are some cases where this is what you have to do to get the features you want. For example, if you're building a CDN, your whole point is to deliver content to everybody regardless of origin, fine. You can add this header to your responses. If you add this header to your responses, you're saying everyone is allowed to access this information from any origin. Now, this is actually common. I'll backpedal a little bit. This is actually common for things like APIs. If you have an API where the whole purpose is people access your endpoints and interact with your data from anywhere, you're probably going to allow most origins, at least. And maybe not. Oh, yeah. Sorry, I was thinking ahead of myself. So the star means anything. So allow from any origin to be able to request from this. Don't do this. There are tutorials. There are plenty of tutorials out there that say, and like Stack Overflow questions and stuff. Stack Overflow is pretty good about, at the very least, the comment section will be like, no, don't actually do that. But somebody will ask a question like, I'm getting this cores error in my browser. How do I fix this? And someone would be like, oh yeah, just allow origin star. Oh, hey, that fixed it. And then somebody should kick in that conversation and be like, please, please, please don't do that. At the very least, replace the star with your domain. If you have two domains and you actually have two domains that need to communicate and work together, just allow that domain explicitly so you don't have to put a star there. Cores is typically a good thing. We like that the browser helps us out. But it is on the browser side. Everything I've talked about of preventing that, so you build a site and you build your project site and you're vulnerable to cores attacks, the browser says, okay, don't worry, I got you. But if we're relying on that, we are relying on the browser. And browser's part of the client side. What can we trust about clients? Nothing. We don't trust our clients, even when it is the browser. So there's quite a few things that can go wrong here when we're relying on the browser. What if somebody's using an outdated browser? They're far and few between, but people still do use Internet Explorer a few times. If your Internet Explorer users just can't use your site, at this point, I think we can just call that a loss and whatever, move on with our lives. But when it's a security issue, I'm a little less easy. I'm a little more uneasy about that. When it's a security risk and you're saying, okay, these users over here we'll just allow them to be insecure, don't play that game. That's just not okay. But when it is Yeah, if they just can't use your site, whatever. But if they're, I already said it. Some people, I've seen some students do this, install plugins that override CORS. There are plugins that will disable CORS on your browser. So the browser, when you're browsing the internet, you have full control over your browser. Maybe not easily, but you do have full control over your browser. It's software installed on your machine. You have to have full control over it. In one way or another, even if that control means going through machine code and decompiling it and figuring out what it does and then changing the machine code of the executable itself. But that's something you can do. So what if your users disable CORS? They install that plugin that says, I don't want CORS anymore. I'm cool without it. What if they use some obscure browser? If you're not using one of the mainstream browsers, or if you're using Firefox for certain things, like the redirects, still bugs me. But if they're using some obscure browser, there's no guarantee that they implemented CORS correctly. You know, maybe they have, they probably have. But if it's a browser with like 100 users, you know, maybe not. Maybe they didn't. You might be open to a lot of security vulnerabilities if you're using some really obscure browser. So CORS on the client side, not 100%. When it comes to security, we really need 100%. If we're not covering 100% of our users, if we're saying Internet Explorer users, you're vulnerable, users who disabled CORS, come on, that was your own choice, you're done. And the times I've seen the users who disabled CORS were the ones who just were developing an app or whatever, developing some web app, and they had an issue. They said, Internet, fix my issue. They got the solution. They blindly followed the steps and did some cut and pasting and crap like that and had no freaking clue what they were doing. You've probably been there before, where you just get some solution off the internet, you follow the steps, especially if they're like, open your terminal, now paste these 10 commands. Do you have any idea what those 10 commands did? All you know is if it fixed your problem or not. It happens. We all do it from time to time. I've done it before too. But if one of those steps is install this browser extension that disables CORS, which does solve some development problems, they might not even know that they installed that plugin. So are we just going to say, well, they're vulnerable now. It was their choice. Maybe, but they might not have fully understood what they were doing. We need 100%. So the browser's nice. TLDR of that one. Browser's nice, offers a lot of general protections, but it's not 100%. So this class is all about server-side stuff, so let's add some server-side protections against these cross-site request forgery attacks. These are going to work 100%, because every single user of our site has to interact with our server-side code. Like, they don't have a choice. So if our server-side code locks this down and says this ain't allowed, then we're good. And I'll warn you up front, I'll give a little foreshadow. What we're going to do right now isn't 100%, so even that big motivation leading into this. It's not 100% until we have authentication in Homework 4. We haven't learned authentication yet, but with authentication, this will end up being 100%. But without authentication, we're going to use tokens. We can't associate a token with a user, so we will have that little loophole. So if you're thinking of that, yes, that is one issue with the way we're going to do this. Looks good without C. Oh, yeah, and the Piazza logo is a huge P. Oh, it looks so bad. It's real bad. Have you seen the CC 250 course website? If you paste a link to it, I'll have to manually type it over to my laptop, but we'll check it out when we get to the demos. Forwarding every port. Oh my goodness, do they? Wow. Nintendo, come on. So in chat, for those of you not looking at chat, how to get multiplayer to work, Nintendo recommends forwarding all ports to your Switch. Why is that? What? What's that?
I just Googled, I read saw it on Reddit a while ago, but yeah, this is still on Google's support site, or Nintendo's support site.
Jeez. Yeah, I mean, I wouldn't believe it if I wasn't looking at it. For Nintendo Switch console, this is port 1 through 65,000. My eyes. 65,535. Forward every single port to your Switch. What? Doesn't that break things? Can't you not use your browser anymore? No, well, maybe not. If they're doing these kind of things, that's why they're getting some security issues. So let me, since this came up, I'll give a little background. It's off topic from cross-site request forgery, but we got some time in this lecture. So port forwarding is, so your router is set up to communicate to your whole network, your whole LAN, all your devices connected at your home. Everything goes through that one router, and that router has a public IP address. Only one public IP address for the whole household. So when you get data over that IP to that IP address, the router decides which machine to send it to. With port forwarding, so say you have you want to play games on your Switch or your desktop or something, you're going to have to forward a port, whatever port that gaming console, or what's the general term? That game, I guess I'll just say. Whatever port that game uses, they'll choose some port, usually in the higher-ish numbers. And when you try to play multiplayer, usually they're going to say, you have to forward this port to your machine. You go into your router settings, and you say, hey, router, whenever anything comes over this one particular port, send it to my desktop, because that's where I'm gaming. So then when you get requests for that game, your router's going to say, oh, this is for the desktop. I'm going to send it there, and then the desktop gets the game information and does its thing. So Nintendo Switch says, no, we're not going to pick a port. We're not going to say this is the Nintendo Switch port. They're saying every single port. So anything that comes across the internet, send it all to the Switch, which just sounds like opening yourself for all kinds of attacks. Now, any information sent to your router is sent to your Switch. You basically open up your Switch to the outside world, and anybody can attack your Switch and launch any vectors they want to throw at it. Nintendo, yes. Hey, my new website. Can our token be emojis? I don't see why not. All right, so cross-site request forgery tokens. This is how we're going to prevent against this attack server side. And this is the whole thing in one slide. This is, it's a lot of text, but this is the idea. This is what I expect you to do for Objective 5 of Homework 2. Whenever you get a page load, whenever somebody says, hey, give me your index.html, give me your page. What you're going to do is generate a token. It can be any long random string, as long as it's long-ish enough that people won't guess it. We don't have any strict entropy requirements of how long it should be and whatever. Should you use special characters? But it shouldn't be 1 and 2, like an auto-incrementing like we did for the API. Make it at least look like it was randomly generated, or it should be random. It has to be randomly generated. What am I trying to say here? Make sure it's random, I guess. That's the big thing. And not like a random number between 1 and 10. Make it reasonably random. But we don't have any strict requirements on what that means. If you do 10 random characters, you're certainly passing that requirement. And then you're going to embed this token into your page. So the page loads. You're going to embed this into the page, usually as a hidden input in your form. So you embed that into the page, and then store this token. I don't believe I put a database requirement on the tokens, but if I did, you have to store it in your database. And then for that part, you're done. You got a request, generate a token, send it to the user, store that token. In your browser, the user doesn't even know this token exists. They're none the wiser. And whenever they submit, that token's sent along with the form. So for our purposes, this will be a hidden input in the form. But we can do this. We can get fancier with this later on once we know AJAX. But some way you're going to hide that token from the user just because it's gross UX if people can see the cross-site request forgery tokens. We're not trying to hide the information from the user. But then send the token whenever they make a submission. Now at the server, we're going to check that token. If that token is a token that we issued, we're going to say, OK, this is a legit request. If that token cannot be verified, if it's not a token our server issued, we don't handle that request. We'll probably do nothing and respond with a 403 forbidden. You're not allowed to do that. So if they don't have a valid token that was issued by your server, don't respect the request. Don't handle that request the way you normally would. And this is cross-site request forgery tokens. For your homework, we have a few things to keep this fairly simple. If you get any valid token, you can accept the request, so you don't have to remember which token went to which user. Every time you get a request for your homepage, you're going to generate a new token. And whenever you receive a request, as long as that request contains any one of those tokens, then you're going to call it good. Now, at this point, there's still an attack vector. With that specific setup, an attacker goes to our site legitimately, just goes to the browser or sets up Postman and sets up some script, makes a whole bunch of requests to our site, and just collects a whole bunch of tokens. And then in their attack site, they start filtering through those tokens using one at a time. When they run out, they go to our site and get more legit tokens. So we're not exactly secure the way we're going to do it in homework 2. We only have so many tools in our toolbox right now. But we're talking about forms. I want to talk about cross-site request forgery right away. So what we'll do, I don't know if it'll be part of the homework, probably not. But what we can do after homework 4, when we have authentication, is associate the token with a user who was authenticated and logged in, and now there's no attack vector. So the attacker can come to our site and get tokens associated with their account, but that doesn't help them when they're trying to attack your account. It just doesn't help. Doesn't do anything, because they'll set up their attack, the token won't match that account, and nothing happens. And that's really where where the attackers want to launch these attacks as well, is when you're authenticated. So if you're not authenticated and anyone can go to your homework 2 site and upload an image with a comment, there's really no point in attacking you, because they'll just go to the site themselves and upload that stuff. But once you're authenticated and they can attack you, you're authenticated over here, you visit this site, and now they send something on your behalf as you, because you're authenticated, now that's an issue. So once you're authenticated, we get stronger protections. It's more lucrative for the attackers to actually attack you, but we also get the stronger actual full protection of cross-site request forgery tokens. The alternative to that would be associating the token with an IP address, but it's always a dicey game. Your IP address can change. Like UB can just change your IP address, especially as you're moving between access points. So we don't really like playing those games. Our legitimate users get diminished results there, a diminished experience. So we can use a hidden field, a hidden input, which can look just like this. This would be the HTML. So that value, that's some random token that I generated. And you can use, people ask this every semester, you can use a library. If you want to use the secrets library to generate your tokens, go for it. Knock yourself out. I don't want to assess you on your ability to generate a random token. I believe that every single person in this room can generate random tokens that look like this. And you'll do it in like 5 lines of code. It might take you a little bit, but it's just tedium that I don't feel like making you go through. There's really no point to it. If you import secrets and say secrets, give me a token of length 20, do it. Go for it. I'm calling it my XSRF token, and I'm putting this hidden on here. This hidden attribute, it's an attribute with a name and no value. Slap hidden on it, and the user won't be able to see that input. They can see it if they view source. Like, it's not secret information. It's just information that they don't need to know. There's no reason for a legitimate user, to ever notice that these exist. Just like you've probably used the internet your whole life without ever noticing these tokens exist, unless you explicitly studied it. But they're all over the place. They're in all kinds of forms that you submit. And when you receive the request, you have to parse your multi-part one more. This is where it's going to really pay off if in objective, right from objective 1, you write some generic multi-part parsing code. I know a lot of students like to just pick out the key information and make strong assumptions about the multi-part. Like the first one will always be the comment, the second one will always be the image, which are pretty consistent across browsers. But what happens when you change your form itself? You add this token. It might break all your parsing if you didn't have nice generic parsing code. JS demo Wednesday, actually. I'm glad you asked. All right, so the browser with cores is going to help to prevent these attacks, but we're not going to rely on the browser. We're going to do some server-side stuff and issue these cross-site request forgery tokens. So let's do this before we get into the demos. And holy crap, that took 35 minutes to go through those slides. With only a few side stories. Three characters, take it or leave it. If it's 3 random characters, I'd be fine. For your grade for this assignment, as long as it's not like, I don't know, as long as it's not 1 character, I guess, or 2. I think 3 would be about the minimum. 2, I'd be like, come on. You couldn't do more than that? Especially when it takes like 0 code to make a longer token. Are we going to go over JWTs? Not explicitly. I can right now. To my recollection, JWTs just is a token, just like we saw with the cross-site request forgery tokens. It's going to be some long random string. But JWTs are stored in a JSON format, a very specific JSON format. And I believe, this is where I actually had some confusion on this. I'll have to study up some more. I believe JWTs are usually stored in local storage and not in cookies, where other tokens are, when we get to auth, are going to be stored in cookies. They're stored in local storage and then read and sent on request. But that might have just been one of the use cases of JWTs as well. I think you can still put them in cookies, but I'm not 100% on that stuff. But it's a very specific format of token that, to be honest, I've never found that interesting every time I read up on it. JWT is just a fancier token. Like, it doesn't add things that you can do. It doesn't enable new features. Please type your cross-site request forgery token. Goodness gracious. Okay. Let's see if I got all my stuff set up. Okay, I want to send, let me send just a regular GET request to buffalo.edu. Of course, I messed it up already. I actually want to start with this one. I might not even use this code, actually. I can do everything I want right here. Duplicate, comment, get. All right, so here's just a very simple, let me start my server. Very simple GET request, but I'm using Ajax. I assume a lot of you might have seen Ajax at one point or another. I believe we still do Ajax in 199 when you would have taken it, I believe. But if not, I'm creating a request using this XML HTTP request object, which is terribly named, not terribly named for the time, but that name just stuck, even though we're in modern day, back when requests were based on XML and stuff. Anyway, this is going to be an Ajax request. So we're creating an HTTP request. I'm going to set some properties of it. This onReadyState change is going to be called whenever the ready state changes. I'm going to have this conditional which says, when I got a response from this request, do whatever. We're not actually messing with that part. In this demo, we don't need it. We don't need to do anything with the responses. I'm going to do everything in the browser console. The important part is down here. We're going to open the request, give it a method type and a URL. I'm going to make a cross-site request. The origin here is not localhost port 8000, so this is a cross-site request, and I want to see what my browser is going to do with it. And then when we hit send, it's going to fire off that request. This will be an AJAX request. It doesn't require a page reload. We're just going to fire this off using JavaScript. Oh, that's by JavaScript demos you meant, no, we're not going to see JavaScript demos on Wednesday in that sense. We'll see client-side JavaScript demos on Wednesday, not server-side if that's what you meant. But at this point, we're at a point where I can't distinguish between legitimate requests and trolling when it comes to JavaScript, so I probably won't show any JavaScript just because of that fact. I don't know who's trolling or not anymore. But if you're, I don't know, if you're not trolling, I don't know, send me an email or something. We could talk about it. All right, so let me go to my browser. Actually, don't need Postman today. Localhost 8000. And the action already happened. Let's go to our browser console. I'm going to check out network. Close this thing. I don't know if that bugs y'all as much as it bugs me, but that's one of my pet peeves. Every time Google updates anything, it gives me this huge lower third that I have to close every single time. Anyway, so I made this request for buffalo.edu. It actually sent a 302 for some reason. Is that a typo? Why would it send a 302? Anyway, I got a CORS error. It's not allowed. This request is not allowed. Browser is going to disable this or not allow this, and I'm going to get an error that says, hey, they didn't set this header to your origin or to star, so this flat out isn't allowed. You can't do this. So even just a simple GET request, we already got shut down by CORS. And that's not something that buffalo.edu had to do, because if they did, they might have messed it up. But if we get something, I just want a nice static image that's actually an image. Are these actually images? Copy image address. .jpeg, okay. Whoever that is, let's, just so we're not picking on an actual person, let's get the bowl here. And I'm going to go back to my code, and instead of a GET request for buffalo.edu, the HTML, I'm going to request some multimedia. Do the same thing, refresh, and it got blocked by CORS. That's what I expected to go through. Well, all right. So I have it commented out in my code. I had one that worked right here. Wikipedia, from the CORS article, I was doing my research. This PNG from Wikipedia, this I know works because I did this in my testing. This, when we get this, we actually get the image itself. So we didn't get blocked by CORS here, and really curious why that Buffalo, oh, they do explicitly allow. So we get the allow origin. This allows requests from every origin for that picture. So this is going through probably their CDN, upload.wikimedia, is going to allow the cross-site request. So we actually do get that because they explicitly allow that content. Now, if we request any, maybe we want to start deleting things. If we make a request with a different method, which we could probably see in here, specifically put, delete, and a few others. Cores is going to be a little more involved. There's going to be a little bit more action that happens here. So the delete got blocked. We can only get that image. We can't delete that image or put that image. We can't do any of those verbs. We can't use any of those verbs with it. If we look at what happened here, we actually got 2 requests. One was the delete, which was blocked. We can verify in our console, blocked by cores. Method delete not allowed by access control allow methods. In pre-flight response, what does that mean? Well, whenever you try to make one of those requests, something that's not a get and something that's like a delete and post request, you're going to get this second request, which is called a pre-flight with the method options. So this is going to check, it's going to check the server and say, hey, what do you allow for this path? Instead of just trying to request it and getting cores, how do I want to word this? So if you just requested the image, how does that server tell you that that's not allowed? Does it send you the image and say that's not allowed? Because the server doesn't necessarily know that this is a cross-origin request. So how would it tell you it's not allowed without just sending the information with some headers? It's up to the browser to block this stuff. So when it's something that's questionable, what the browser is going to do is send this options request. And what this says is, hey, server, send me just the headers of your response without any of the data. And then I'll check the headers and see if this is allowed. So we check the headers and we get allow origin star. Okay, we're allowed to make this request. But when we look at the methods that are allowed, it's saying you can make this request from different origins, but only if it's a get header options request. So now we know, okay, we can only make get header options requests. We can make the get request, but my user's trying to make a delete request. I'm going to block that, and I'm going to not let them send this request over. Oh, the 250 site. The site from this semester. Ken Regan teaching it. Oh, there's nothing wrong with that. I mean, there's zero styling, but it gives you the information you need. I ain't mad at that. It's what? Oh, yeah, in a dark room for sure. But that's the information you need. I actually really like sites like this, where it's here's all the information. Assuming all the information is here. Here's the information you need. Nothing more, nothing less. No styling. I was talking about Bootstrap at the time, so I assume that's the comment. There's no styling there. But that's fine. Not everything needs styling. Yeah, JusteleeHartloff.com. Woo. All right, so I want to show that one. And also, oh, did I not? Oh, right. I'm like, why did I even have this here? Because I'm dumb and I forget things. All right, so here's obviously just a test project. And I don't like this demo, but I'm going to do it anyway. Sign up for GitHub. Oh, crap. Am I really not logged in on this browser? Why do I have a sign up but not a sign in option? Am I zoomed in too far? I am. Oh, son of a bitch. How do I even... Why are there no options? We sent you a sign-in request on your GitHub mobile app. I didn't get any notification. I'm probably not logged in on... I can't get in. Well, I can't log in time. Oh, yeah, I want my authentication code. I know how to do it this way. And now I'm not in dark mode. All right, so we got there. Issues, new issues, inspect element. So here's the page to create a GitHub issue. If I go to elements and I just search, oh my goodness, come on. I did S for search because I was saying search. Cross-site request forgery, they use a C. And we can see all these hidden inputs with very long random tokens for the cross-site request forgery tokens. We only got 2 minutes. I'm not going to go through the whole demo. But what I do is mess up these tokens and then submit. GitHub actually still accepts the requests. I don't know why. Maybe because it is authenticated. Maybe they look at my authentication token, and I don't know. But I was playing with this and messing up the tokens, and it still worked. What should happen is if I mess up this token, and there's a whole bunch of tokens. There's several tokens on this page. If I mess up these tokens and then submit the form, it shouldn't be allowed. So for your Homework 2 server, I mess up this token. That wasn't a token that was issued to you, to this user. It shouldn't be allowed. And, because I know a lot of you like to cheese this, what we're going to do explicitly, it's in the testing instructions. We're explicitly going to check for this. If we append characters to the end of the token, that should also be rejected. That's not a valid token. So those of you who like to do if the entire request ever dot contains my token, then accept it. It drives me nuts seeing that. It's become one of my pet peeves. Like, you're not doing any parsing. You're just saying, does my entire request contain the token? No. So we are going to append to the end. You actually have to read your damn tokens. So we will test for that. Just a heads up. All right, we're at the end here, so have a great day, and I'll see everyone Wednesday.